Hello, welcome. Today we're going to be looking at transport phenomena. Transport phenomena. This is a course that is always in chemical engineering and physics. What do you understand by the term transport phenomena? Transport. If you have a conductor of this length, for heat that you are applying at this end of the conductor to get to the other point, so that when you touch the conductor here, you feel the heat. There has to be transport of heat energy from the point where the source is applying it to the conductor to that point that you want to feel it. Transport of heat from one point, source, to that point. If somebody sprays a perfume here, and you are on the other end of the room, you want to perceive the smell of the perfume, there has to be transport of the materials from the perfume to the side that you are for you to perceive it. Transport of materials, transport of energy for the conductor, transport of material, diffusion of the odor or smell, the fragrance of the perfume to the other side, transport. You understand? So in physics and in chemical engineering, you always see things transporting from one place to the other. When you have your tower, your separating tower, you also, when you pass in your feet, for your feet to be separated into the top and bottom, it has to be transported. Transport phenomena. So what is this transport phenomenon? Transport phenomena involves the movement of various entities such as mass, momentum, or energy through a medium, which could be fluid or solid, by virtue of non-uniform conditions existing within the medium. So whenever entities like mass, momentum, and energy move, we call it transport phenomena. Like when energy that you are applying on one side of the conductor gets to the other side, the energy is moving. So we'll call it, in normal term, we call it conduction, but it's actually transport of energy. When the fragrance from the perfume that you spray there is getting up to this place, the mass is moving. So it could be, mass could be moving, energy could be moving, momentum in fluids could also be moving. So whenever you have the movement of these various entities, either mass, momentum, energy, through a medium, which could be fluid or solid, by virtue of non-uniform conditions existing within the medium, we say that we have transport phenomena. Very, very simple. Now, what are these entities that can be moving? These entities are always conserved. When we say conserved, we mean that they are not destroyed or newly produced. So the quantity that you give in is always the quantity that you get out in the end. They are always conserved. And because they are conserved, you can write this rate equation. You can say that the rate of input of any of these quantities, whether it's mass or energy, which we represented with this sign, the rate of its input, the rate of input of mass, the rate of input of momentum or energy, minus the rate of their output, plus the generation is always equal to rate of accumulation. This is very, very important. This equation holds for mass, momentum, or energy. And that brings us to what are the things that can be conserved. What are these things that can be conserved? You can conserve chemical species in moles, mass, momentum, or energy. So any of these things that can be conserved, you can always write this rate equation for them. Very simple rate. Rate of input minus rate of output plus rate of generation is equal to rate of accumulation. Very, very important. This holds for any of them, whether it's mass, momentum, or energy. So any of these quantities that can be conserved, you can always write this general conservation rate for them. So this, when you break it down now, you get the various equations like the Fourier's law equation, you can get fixed law equation, you can get any of those, which are specific for any of the entities that can be conserved. Now, very, very important before we start deriving, before we start taking this to steady state, uniform and non-uniform and equilibrium state, it's always good that you know that whenever you have a notation like this, where this sign is equal to this and in bracket this simply means that this quantity, unknown quantity, is actually dependent on all these. These are called independent variables. These variables, they don't depend on anything, but these ones depend on them. So that's why when you write it, you put them in brackets. It simply means that this is dependent on all these ones. So, but all these ones are independent. These ones are independent, but this one is dependent. Because this is dependent on this, you can say that this is a function of t, x, y, z. So what are these things, these variables that this quantity which could be mass, momentum, or energy? What are these independent variables that it is dependent on for you to call it a function of all this? So this quantity is actually a function of three independent space variables. You know space, whenever you're writing space, it has to be in this form, where you have this to be, you can have this to be x, y, and z. So these are space variables, three independent space variables. Then t is a time variable, it's also independent. So like I told you, everything here is independent, both the time and the other three space variables. But this is dependent on all of them. That's why this is a function of all of them. And this can represent either mass, momentum, or energy. So this is an introductory class to transport phenomena. Like I said, transport simply means whenever you're transporting, whenever there is movement of any of the entities, and those entities are energy, mass, and momentum, whenever they are moving from one point in a medium, and this medium can be solid or fluid, moving from one point to the other, call it transport phenomenon. You can utilize transport in so many things. It is what happens during conduction, during convection. When you boil water in a kettle, the hot water that has less density, once they are heated, they go up because of their less density. Then the cold ones with big higher density come down. There is movement. That movement, convection movement, convective movement, that's what causes boiling. That's what causes all the parts of the water to get boiled. So that convective movement is an example of transport phenomenon, because there is movement of the medium from or movement in the medium. So whenever we have such thing, when you are having a mass transfer, like when you're doing separation in your columns, there is always movement. There is always transport of masses. So once there is transport of masses or transport of energy, we have what we call transport phenomenon. And this is the general conserved rate equation that governs any of them. And this can represent mass, momentum, or energy. So in subsequent classes, we are going to be reducing this rate equation to when we have steady state, when we have uniform condition, when we have equilibrium condition. So please, if you like this our lecture, subscribe to our channel so that you'll be getting subsequent lectures like this. You can like and share this video. Thank you. Get down the notes while we wait for the next class. Thanks.